So I'm going to just do, let me talk about what we're going to do today. I'm going to give a quick introduction on WhereScape, who we are, what we do. I'll introduce Kent. And then we're going to have a conversation about data modeling, AI, machine learning, all sorts of fun stuff. I've been looking forward to this for quite a while. I've been doing a bit of research, and one of the reasons I like doing these kinds of presentations is I've got to get more background information and I learn more things, as I hope all of you will as well. So WhereScape, we're very happy to sponsor this. Very glad you could attend. WhereScape as a company has been around about 20 years. We started as a consulting company in New Zealand, doing projects, building data warehouses. And we realized there were a lot of repetitive tasks that we were doing. So we started developing tools to automate that. And productivity went through the roof. And some customers started asking us, what are these tools? Can we buy them? And at that point, WhereScape stopped being a consulting company and started being a software development company. We've got about 1,200 customers around the world. They're not tied to any particular industry, manufacturing, health, government, academic, pretty much anything, even the nonprofits, pretty much anything you can imagine. We've got customers in those areas. And we're not tied to any particular technology or any particular methodology. We support officially 17 different targets, including obviously Snowflake, SQL Server, Oracle, Google BigQuery, a lot of those, but also now Databricks. We just in the last month or so, we released an enablement pack that allows you to use WhereScape to develop on Databricks. And the big key to what we do is automation. Automation takes out a lot of the drudge work, repetitive work, hand coding, takes out a lot of the interactions that introduce errors. And you'll see in a second, develops a lot of consistency. Data warehouse automation has been around 15 years or so. I guess that's about as long as WhereScape has been developing data warehouse automation tools. And there's 5 main factors about why automation is a good thing. Obviously, cost. The things that come to mind immediately are labor costs. If I'm being much more productive, that means I can develop things faster, reduce labor costs. I started life as a programmer, both on Unix and DOS to date myself. And I always tell people that as a programmer, I spent 75% of my, or 25% of my time actually writing code and 75% of my time debugging it, or just getting things to compile in the first place. What automation does is by removing almost all of the hand coding and by using standardized templates and best practices, I've got something that will compile and work the first time. And that really accelerates the productivity I can get out of this. Risk, there's a lot of factors of risk. Staff turnover, for example. You may be brought in consultants to help you design your data warehouse, and they've left, or you've got employees who have left. A lot of knowledge goes out the door with them. With data warehouse automation, all that knowledge is captured as metadata. So I can not only generate documentation, things like that, but I know also that everything that's been developed has been developed in a standard and consistent way. So I've got a new person coming in. I don't have to worry about them learning as many standards. There's obviously standards they still need to learn, but a lot of the work they're going to do, a lot of the work they're going to generate is going to be generated in that same standard way. Complexity, I mentioned Databricks. A couple of years ago, even a year ago, I'd barely heard of Databricks. We started hearing prospects talking about it. We looked into it in a matter of a few months. We had an enablement pack, a package that now lets you use WhereScape to develop for Databricks. As targets get more complex, as sources get more complex, whether you're pulling from JSON files or web APIs or whatever it is that's out there, that's going to change in the next few years. As design methodologies change, data warehouse automation allows you to adapt to this quickly. Urgency. COVID showed as a very good example of how fast businesses can spin on a dime with their needs and requirements. Things are always needed today, if not yesterday. And what data warehouse automation allows you to do is to not just develop faster, but maintain and modify, refactor things faster. If I have to modify a business transform to meet a new business requirement, with automation, I don't have to learn 10 different coding styles because 10 different people worked on it. Because of the consistency, because everything else, I can develop things much faster. And that leads to agility, meaning that because I'm more productive, because I can generate things faster, I can generate templates prototypes much, much faster. I can bring in a business analyst, show them a working model of a data warehouse. They can use the tools they're familiar with, whether it's Tableau or Power BI or Yellowfin, whatever it is. And if they need a transform added or a change made, I can do that right in front of them and work much, much closer with the end users to develop a product that's available faster and more suited to what they need. Because I've said many, many times, when you go ask a data analyst what it is they want, their response is always going to be, well, what have you got? Rapid prototyping allows you to bridge that gap where you can show them what you're capable of, and that helps them figure out exactly what it is they're looking for. So today I'm going to be talking with Kent Graziano. I've met Kent several times in person and on camera. Award-winning author and speaker, known as the Data Warrior. Lots of experience in IT, data warehousing, analytical solutions. Data Vault Master has been working with Dan Lindstedt for probably as long as Data Vault's been around. And this is something new. Yeah, this is something new I didn't know about. He's an 8th degree black belt in Taekwondo. Now, I took Taekwondo for about 6 months, many decades ago, but I think I'll leave that off my resume. And Kent's also been working with WhereScape for about 15 years. You said you had gone to a seminar and someone from WhereScape was presenting a demo, and you looked at it. Can you tell us a little bit about that?
Sure. Yeah, it was actually back when I was in Colorado. I had, for a number of years, been presenting a talk on applying Agile principles for data warehousing, because it really hadn't caught on to use Agile in the data warehousing world. And I went to a local TDWI meetup in Denver, and here's this guy, his name's Raphael, was doing almost exactly the same presentation that I was doing, like point for point. I thought he stole my presentation, except that in between he was showing screenshots and talking about automation, but he never mentioned the product. And at the end, I was like, well, okay, are those screenshots real? And he's like, yeah. So there's a product that does this for data warehousing, because I had been in the Oracle case world and Oracle Designer and been generating OLTP apps in the 90s. And so I knew about code generation and had never seen one that did it for data warehouse. And he goes, oh yeah, this is the company I work for, WhereScape. It's like, we do data warehouse automation. And that was like light bulb went off. And Raphael eventually he got into Data Vault, and I helped mentor him on some Data Vault modeling he was doing using WhereScape back in very, very early days. This was the first iteration of Data Vault. So it was like 2009, I think. It was about the time. It was 2009, and got to be friends with him, and eventually got to meet some of the senior people at WhereScape, and formed a close bond with them, because I was very interested in being able to generate data warehouse type things quickly and easily with applying standards, and eventually got WhereScape to partner with Snowflake when I went to Snowflake. So it was probably the first generation tool that was available to build data warehousing type structures and data vaults and things on Snowflake.
And I think you have the impression that I had, that I know a lot of WhereScape employees have had, and a lot of our customers have had when they first see WhereScape. It's just amazing what data automation can do, how fast it can create things for you. And as I've said many, many times, things work the first time.
Yeah.
It's also just become an incredibly flexible tool. I'll remind everybody there's a Q&A button on there. If you have any questions, feel free to type in any questions you have, and we'll try and fit those in as we go along. But today's webinar is going to be just kind of a free-flowing conversation. I'm going to ask questions mostly, and Kent is going to give a lot of answers. So talking again about data automation, I'm going to go ahead and just stop screen sharing, because the focus is going to be on our conversation. May bring that back up. But today, like I said, we're going to talk about data modeling, the importance of data modeling in an AI world, world where artificial intelligence is increasingly taking over, and if not taking over, at least supplementing a lot of work that people do, a lot of business decisions that are made, a lot of business operations. So the topic of the conversation was is data modeling more relevant now than it was in the past in the new world of AI? So Kent, just a very, very basic question. Can you in a couple sentences just talk about what data modeling is, what it isn't, how it's evolved over the years?
Well, yeah, I mean, it's been around for quite a while, from very early days of my career. I mean, it started long before I got into IT, but back in the day we called it entity relationship modeling. And it was all about normalization and how to structure data to be efficient inside a relational database, and all that pioneered by EF Codd and CJ Date back years ago. In fact, I just heard a keynote from CJ. He's got a book out about 50 years of relational and the history of all of that. So it's been around for quite a while. And so when we talk about data modeling, one of the things in a recent conference I was at, we had this conversation about, a lot of people just say modeling, right? And so we want to be a little more specific. We're talking about data modeling. We're talking about basically elucidating the structure and relationships within the data that a business cares about. I mean, you can model all the data in the world, but we want to be business focused. So we're really looking at, well, what does the business care about? And in our conversation here, as we were talking about, moving into the age of AI and LLMs, large language models and generative AI and all of that, I maintain that it's even more important now that we get back to some of the basics and the principles of data modeling that have been around for 50 years, and that it's really important for us to get back to those, I'll say, practices in the world of data management, is having data modeling, making sure that we understand not only the structure of the data, but the content of the data. What's there, and that includes the relationships and all of what we used to call metadata about the data. Things that people care about and need to know in order to understand the data. As if we're going to try to get AI, artificial intelligence, one of my colleagues calls it augmented intelligence, is another way of thinking of it. Not necessarily art, even though it's artificial. It's not. By that we're saying it's not the human brain, right? What we have in the human brain is our natural intelligence, but we have through the use of technology now the ability to have augmented or artificial intelligence. But that all has to be based on something. And I maintain that having good data models is a critical success factor to being successful with implementing AI these days.
I was surprised in doing research for this, we talked about this a little earlier, that there's actually ANSI standards. Obviously, there's ANSI standards for C, for SQL, SQL, for all that. But they actually reference data modeling, and that goes back as far as 1975, that ANSI was talking about conceptual model, logical model, physical model.
Yeah. Yeah. Well, I'll talk about that in a little bit too, because there is some definite distinctions there between, in particular, logical and physical models with regard to how I think that interplays with artificial intelligence.
We'd also talked earlier about exactly what artificial intelligence is. My understanding was that artificial intelligence was more a task-oriented process.
Yeah.
Such as optical character recognition or automated driving, things which are, like as I said, task-oriented, whereas machine learning to me was more data mining, looking through large data sets, finding patterns, finding useful information out of that. But lately, it seems to me at least, the terms are becoming kind of, I don't want to say co-opted, but commingled. And are used kind of almost interchangeably. What are your thoughts about that?
Yeah, there's, as always has been the case in the IT world and probably basically every industry, there's been an evolution in terminology. Back when I started, the term you used, data mining, that was the kind of term that existed, especially in the early 2000s. People were talking about data mining. But we go back to, even before that, there was talk of artificial intelligence, and it was mostly MIT and a couple other big universities that were doing research and invented languages like Smalltalk to try to do artificial intelligence, but that required such a massive amount of compute, right? That, you had to have a Cray supercomputer, and there was only a few universities and, the US Department of Defense that could really afford those sorts of things. So it didn't evolve a lot, but then along the way, we morphed into, we got into data warehousing, we got into business intelligence, and the data mining was kind of in there. Big pharmaceutical companies were doing some sort of data mining, and they developed these things called algorithms, right? They're ways of examining and statistically analyzing the data, and that eventually became data science. Right? We talked about data scientists who were, PhDs in statistics and knew how to apply different statistical methods to a very large data set in order to do things like projections, right? And forecasting and things of that nature. And then that seemed to have evolved into machine learning. And what I eventually, figured out, machine learning, it's like, what are you talking about? You're teaching a machine. Well, what does that mean? Well, we're going to feed information to a program, right? It's a program. It's a computer program. Make no mistake about that. It's a computer program to try to teach it something. And so the simple example that I always use is if you show the algorithm a bunch of pictures of cats, well then, okay, you showed a picture of a cat or a lion or a cheetah or a bobcat, it's going to say, oh, okay, that's a cat. Now, if you show a picture of it, a dog, if you're lucky, it'll say, well, that's not a cat. But it can't tell you it's a dog because you never showed it. You never said what a dog is. You never defined what a dog is. You never showed it pictures of a dog. And so you've got, cat, 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 not cat. Okay. And so that's what it's learned, right? That's machine learning. And of course, it's way, way, way more complicated and sophisticated than that. But to me, then the next part is artificial or augmented intelligence is a result of taking those machine learning models that were developed through this training and then, making them, somewhat more autonomous, that they can now look at a data set and based on what it learned from the machine learning model, it can make deductions, conclusions, and generate output in some form, right? And so they're related. I think you're right. People do get confused. Like I said, a couple of years ago, we just used to talk about data science and supporting data science workloads, especially when I worked at Snowflake. But then we started talking specifically about machine learning and machine learning algorithms, machine learning libraries. And now we have this thing, large language models, which is really, it's machine learning, but it's at a much larger scale, neural nets and weights and parameters and all kinds of things going against text to be able to do things like ChatGPT, right? It's, people ask it questions and it comes back with really reasonably sounding answers. So much so that, they're worried about kids cheating on essays at college. And I know people who are using it to generate their product marketing material now, right? To get the first draft of it by just, asking a question to ChatGPT about something and out comes the answer. But all of it relies on the data that is input, right? As I said, if you don't ever show the algorithm a picture of a dog, it doesn't really know what a dog is. It just knows the dog's not a cat because all it knows is cats. So this is where we get into the conversation about the data. You've got to have good quality data if you're going to have good quality outputs ultimately from your AI. Because again, it is augmented intelligence. It's taking the information that has been given and, coming up with a result to answer questions. Like I said, some cases it was doing forecasting. And in many ways, it's an advancement on the data mining thing you were talking about, right? Is what are we trying to get out of this AI and how is that going to help our businesses move forward? But it really has to be based on good data. There's been, quite a number of cases, published in the press over the last couple of years about really, really bad outcomes from, say, a hiring algorithm, right? Some large corporations said, well, we're going to eliminate our recruiters and eliminate most of the interview processes. And we're just going to take all the resumes that we get and run it through our little hiring AI, and it's going to spit out and tell us who to hire. Well, the end result of that was, from a diversity perspective, very bad, and violated the corporation's diversity policies and all sorts of things. And, the result was not good. And the reason for that was all of the information that it had for its previous hiring was definitely biased. There had been, definitely a skew in the past as to who was being hired. And because that's the information that was fed in that said, if we're looking for these characteristics, well, here's all the people we hired. Here's what their resumes look like. Here's what their names look like. Here's what their background looks like. Here's the schools they went to. And as a result, when they put in, a similar, I need a software engineer, they got very similar results. They went through their thousands and thousands and thousands of resumes and got pretty much this, I'll say almost clones of the people that they had previously hired. And they say, okay, that's really not what we want to have happen, because it discarded all kinds of very qualified people because their characteristics didn't match what was in the current pool of people that had been hired over the last couple of decades. And so that's where, the quality of the data, and, sometimes there is innate bias in the data set. And so you can use a biased data set and end up with not the results you want, right? And which is not going to be good. In this case, for the company, it was very bad PR for them. And they had to do some thinking about that and some remediation, and basically had to throw the program away and say, okay, we cannot use this approach to our hiring. We've got to put humans back in the loop, because our AI really didn't do what we want, truly what they wanted to do.
Yeah, the phrase "garbage in, garbage out" has been around for a very, very long
Exactly.
time.
Right, and it still applies. And it's like, yeah. AI can't necessarily tell what the garbage is, because in some cases it can be very subtle. Dan Lindstedt wrote an article a couple of months ago about poison data, about people seeding bad information on purpose as, we'll say, kind of a level of corporate espionage. It's not hacking, but it's, you put data sets out there that are definitely skewed and with incorrect information, knowing that one of your competitors is going to pick that data up and try to do something with it, and that potentially costs them a lot of time and money, because the results are not what they're looking for. It's because they had a deliberately bad data set that someone gave them.
Yeah, I think of garbage in, garbage out as just being corrupted data, bad data. But you mentioned biased. That's also true. I remember one of the first stories I heard about artificial intelligence was a process that was supposed to recognize pictures of people smiling versus pictures of people not smiling. And what it eventually learned was to tell the difference between outdoor and indoor photos, because the data set was set so everyone was smiling was outside, and everybody who wasn't smiling was inside. So yeah, garbage in, garbage out is, like I said, easy to think of corrupted data, but biased data is also another thing for that. You mentioned this company using artificial intelligence to process resumes. What else has been happening in the last few years in the way that businesses are using AI and how they're letting it drive operations?
Yeah, it's
maybe it's in general terms.
Yeah. Finance companies are trying to do forecasting with it, right? And there's actually retail companies in particular. And there was the COVID pandemic caused a problem with data, because patterns changed. And so lots of organizations that were trying to do forecasting and really evolve and to do some more automation, things like that, the data sets they had that they were relying on were prior to COVID. And it turned out during COVID, people's buying habits changed. People's travel habits changed. And we all are very, very much aware of how drastically things changed. And this was another one of those lessons of garbage in, garbage out. It wasn't garbage. It was good data. It was good data at the time, but the climate in the society had changed so much that it was no longer relevant for predicting what needed to be happening now. And so they had to, modify their data set. So instead of looking at all of history, they had to just look at things, from basically March 2020 forward for a little while to try to predict what was happening. So you see that in the retail world. I get pop-ups on my phone all the time from a number, the pharmacies that I use that are very well known, that, that it detects that I'm in the neighborhood, right? Based on the GPS. And it goes, oh, Kent's shopped here at this store. He's 100 yards away. Let's send him a little notice with a $5 off coupon and see if we can get him to come in. Right. And so that's a proactive campaign, automated, based on the information it has about me and my buying habits and my proximity, real-time proximity. Where is Kent right now? Oh, hey, we just sensed that Kent's within 100 yards of one of our stores. Let's send him a coupon. He hasn't been in for 3 weeks. So let's send him a coupon and see if we can get him to come in. So retail, huge applications there. So in the finance world, of course, people are trying to predict spend. Very important now, especially with the economic situation, and interest rates are going up. Inflation is now coming down. They go, what are people going to do, and what does that mean to our bottom line, to our revenue? So there's a lot of areas where you can see this, and then of course in healthcare. There's many applications people are thinking about and trying to do there, all with the goal of improving patient outcomes. So being able to send something proactive to a customer and say, or to a I guess they call them a client or a patient, and say, hey, we've looking at your blood test for the last 3 years. We see that you probably should get checked for this. Please contact your primary care physician and set up an appointment. Trying to be proactive and get people to take care of themselves, better and sooner, so that they don't have worse results later down the line because of some symptom they might not notice that they have, but the AI can look at the patient's history and go, yeah, hey, I see a pattern here. I see a pattern here that indicates we might want to take a couple proactive steps here.
You mentioned the pharmacy and it detecting you within half a mile or so and sending you a coupon. At WhereScape, we've got several customers who are major league sports teams, both on a couple of them are using it on the Moneyball side, on the team side, and a lot of them are using it on the operations side. And one of our customers is a major league basketball team, and they've got an app using their data warehouse that after the game is over, will detect, say the home team won. Hey, you're within 20 yards of a souvenir shop. Why don't you go in and pick up a jersey to celebrate this victory?
Yeah, there you go.
Very, very, very targeted marketing.
Yeah, exactly. Yeah.
We talked about AI. We've talked about garbage in, garbage out. We talked briefly about data modeling. So how does data modeling reinforce data quality and accuracy?
Well, I'll say data modeling done right, which is always the caveat, right? Are we doing it right? You're looking at the relationships between the data, and we'll just talk. We'll restrict ourselves for the moment to basically the realm of entity relationship modeling, relational databases. We talk about things like referential integrity and unique constraints and primary keys and things like that. Is if you're able to understand what that is, that helps ensure that the data you're looking at is good, that you don't have duplicates. I mean, very simple, right? Don't have duplicates. You don't have orphan records. You don't have sales orders that don't have a customer associated with them, right? And that's part of what we get when we do the data modeling, and we know we've modeled things like, every sale must be for one and only one customer, as an example. All right. Well, if there's no customer record, and you've just got random set of text files or CSV files that have all this data in it, and you've got some sales, but there's no customer ID, well, then you don't know who that order belongs to, right? And there's some interesting data quality testing that can be done there. It's like, how many sales orders do we have without customers, right? Obviously we've got an issue in our order entry system that it's not requiring it's either losing the link to the customer or it's not requiring the clerk to enter a valid customer ID for some reason. So there's something broken in the process there. But if you're trying to feed information then, to like a machine learning algorithm of some sort, what's it going to say? Trying to do analysis on your sales and come up with some campaign management sorts of things. And we want to say, well, what kind of customers are buying these things? And if you don't have customers associated with these things, it's going to be really hard to do the demographics to come up with that campaign to send the coupon out to somebody. So it's really important that we have that. And there's a certain discipline to doing data modeling and working with the business to understand the nature of the data. And that's kind of where we get into conceptual and logical modeling, right? Is to understand that from a business context. So as an example, relating this to AI, at the recent Data Vault conference, we did a little experiment with Chat GPT, which everybody knows about Chat GPT, right? You have it generate all these essays and things. Well, we asked it to design a data vault based on the TPCH standard sales model, and amazingly to us, it actually did, right? It generated it and we looked at it. It's like, okay, it had hubs and links and satellites, and it looked fairly reasonable. It even generated the DML for doing the inserts and loading it from the TPCH database. As Snowflake has that in their shared database, so everybody gets a Snowflake account. So it's a very standard one. A couple of us had published blogs doing something similar, and so ChatGPT was able to find it. The problem was all of in Data Vault, we have this concept of business keys because we're trying to do integration, and I know you're familiar with this, Patrick. The business keys were wrong because what it had put in for business keys were the integer surrogate keys from the TPCH database. So what had happened is that, and this is getting to our physical and logical differences here, is ChatGPT, the only thing ChatGPT could find, and this is reasonable because it's the only thing that's out there, was DDL for the physical database design of the TPCH database. And in that, there were primary keys declared, and the primary keys were all integer surrogate keys. And so the only conclusion ChatGPT could come to in trying to define a data vault model was, okay, the business key for the hub is the primary key of the table, right? Which again was a surrogate key, and by data vault definitions, that's not correct. The business key is supposed to be, attributes that define to a human being what that is. So for customer, it's not necessarily a customer ID. For product, it's not a product ID. It might be a product SKU, it might be a product name. But ChatGPT couldn't figure that out because it was only looking at the physical model. Now, if we go over to, WhereScape has this thing called Data Vault Express, one of the products there. And in that, you get the end user who's building the Data Vault model using Data Vault Express, has an opportunity to say, what is the business key? Pick the column, which is the business key. So that required knowledge on the part of the person designing the data vault. And so this is knowledge that the AI did not have available. So how would we bridge that? Well, if you go to, WhereScape 3D, you define the original source model and modify it to show what is the natural business key. In the old world of entity relationship modeling, we called them natural keys, right? We didn't even talk about, when I first started doing data modeling, we didn't even talk about surrogate keys. We talked about natural keys, and in the data vault world, we call those business keys. And so if you have a good data model that has defined the unique identifiers of the object, customer, product, organization, versus a surrogate integer key. Well, now if ChatGPT had access to that model instead of the physical model, had access to the logical model, then it might have produced a better data vault model according to data vault standards. And this is, right down to it's in this case, it's not garbage in, garbage out. It's all the right information just wasn't there. And so the AI made its best guess. And that really drove home for me, the importance of having a good data model. And that includes not just a physical model, right? We can reverse engineer everything we want out of existing databases, but that doesn't mean it actually represents the business perspective. And when I've talked to data scientists over the last 6 or 7 years, and we hear the stories over and over again, how they spend 80% of their time doing ETL and data cleansing and all of this. Well, why is that? Because they started off in the Hadoop world looking at flat files with no relationships, very little metadata, and they're having to basically go do the data profiling manually. Or maybe there's a tool that they can go with to try to figure out what's the relationship between this file and this file. Well, in our world, we would call that, that's a data model. So if they had a data model that they could look at, like the diagram you have up here that shows them, here's all the attributes, here's the data types, here's what they're supposed to be, here's the relationships between those, well, then they don't have to figure that out. And that makes it a lot easier for them to then design like the machine learning algorithm. And if you get an AI now that's going to be able to look at something like this and be able to interpret it, well, again, you have to have trained it using good models, using good complete models, following, what we would have considered, traditional best practices in data modeling, with metadata, not just a couple of tables and some columns and some foreign key constraints, but definitions. What's the meaning of the data in this entity? What's the meaning of these various attributes, and which one of them represent the natural key, and how are these things related, and what's the cardinality? Is it one-to-many? Is it one-to-one? Is it many-to-many? Is it exclusive? Is it mandatory? All of that information leads to a good quality model. And if you have that available, I found out, like I said, with the actual physical data scientists, I was like, wow, yeah, that information would be very helpful for us in developing things. It would save us a lot of time. And of course, if the model and the constraints are enforced in the database, well, that again is giving you that another level of assurance of the quality data, that you've got data. You don't have duplicates in there. They don't have to go write an algorithm now to just eliminate the duplicates. First off, they'd have to determine, are duplicates irrelevant or not? And depending on the model, it may or may not be. But if they had the model that said, this is the definition of the natural key, you should have one row for each of these things according to the specification. Then they know if it's bad data, and they can say, okay, we're going to ignore the duplicates. But then they got to make a call. Do we take the first one? We take the last one. Somebody's got to make those decisions. And all that has to be done by a human being who understands the data, understands the content of the data, understands the business intent of the data, and to a certain extent understands how the data is going to be used. What are you using it for? All of that is important in trying to figure out what we're going to do with all of this data, right? And if we're going to feed it into a machine learning algorithm, and then ultimately into an AI, in the hopes of taking an AI and say pointing it at a data set and asking it questions. If you want to get the right answers, how many customers do we have? What's the demographic profile of the top 25 customers who are buying our top 25 products? Without those relationships, it's not going to be able to get the right answer.
Yeah, you mentioned what I would call source system modeling as a bad practice, and I would definitely agree with that.
In the data vault world, for sure, yes.
Yeah, I was going to say Dan Lindstedt, it really emphasizes that. He says if you do source system modeling where you're starting with a data mart or one subject area, and you model your data vault after a single source system, you've got a 98% failure rate. Because as you said, surrogate keys on one system, as soon as you try to integrate a second system, you're messed up. There's no recovering from that other than starting over.
Right. And depending on the source system, it may have a slightly different interpretation of what the data means than what the business really is looking for. And that's, when you try to integrate, that's where that sort of falls apart, is like, okay, system A was built with this in mind, system B was built this in mind. And they've got some similar concepts, but they might not be at the same, what we call semantic grain, right? One might be a higher level and the other might be a lower level. And I've been thinking about this. It's like, from an AI perspective, it's like, well, how can you solve this? Is it one of the questions we get all the time is, well, can't AI figure out the data model? Well, maybe, but again, if it just looks at one source system, it can figure out the physical model. That's easy. We just call that reverse engineering. Piece of cake, right? Assuming there's constraints in the database, right? Assume you're looking at a database. If you're looking at flat files, okay, then it's going to have to do some data profiling to figure out, okay, what are the unique keys in that file, and are there other files that have similar keys, and is there a relationship there, one to many? All of that, certainly can be done, but to get to the I'll say the business meaning, like we think about in the data vault world, and what's really going to be important for the business people, if you're going to integrate, and you want to say like do automatic integration of data, you have to have something at least like a semantic ontology, right? It might be a graph model, right? A knowledge graph using business terms. Could you feed that to an algorithm and eventually to AI, that it could then come up with, could look at the physical model and look at the ontology and go, okay, I can see, where that is. But even that requires things like glossaries. What does cust mean? Right? CUST. Oh, okay, that's equivalent to customer. All right, well, could it be CST? Yeah, it could be CST too on source system 5. So somewhere somebody has to figure that out. And, some of these LLMs will eventually be able to figure those things out. Because somewhere out there in the universe, out in the interwebs, there's, somebody has done a glossary of some sort with abbreviations. And so there's all these standard abbreviations out there, and it can probably eventually infer all of that. But somewhere along the lines, a human being's probably got to validate it. And the way we tend to validate it in our world is, okay, we build a conceptual and a logical data model and validate it with business people. Is this right? Is this really how this data is related, and in a valuable way for your business?
So that leads to the next question I have, which is, if you're building this conceptual, this logical model in tandem with the business, maybe covering multiple systems, what tools besides Word and Excel, what tools are out there that can help you document what this business model is? I said Word and Excel jokingly, is that's probably what 90% of the people out there use.
Or Access. They think they put a database in Access and they have a data model. Yeah. Well, I see my buddy Mark Cram is asking about ER Studio for data modeling, and with WhereScape. And there's a bunch of tools out there. I mean, WhereScape has 3D, right? That's your modeling tool inside of WhereScape, and does logical and physical models. That was one of your questions, Mark. Mark and I wrote a book together several decades ago about doing a standards for Oracle Designer projects in the Oracle world. And we've always been bemoaning the demise of Oracle Designer for a couple of decades now. But so you've got ER Studio, you've got Ellie, which is with a group out of Finland, Ellie.ai, I think it is.
IO.
IO.
AI. You're correct.
It is AI. It's ELLE, right?
ELLIE.ai.
.ai, and they start off. They're a business modeling tool. You have ER Studio. You have Irwin, which has been around for quite a while. And then in the new world, there's SQL DBM, which is a SaaS-based data modeling tool that a lot of folks at Snowflake use, or who in the Snowflake community use that. The only one that I know that is like tied to generation in the data warehouse world is 3D, right? Is WhereScape. WhereScape's products is the only one that actually ties in completely. So so Mark, is there a way to import ER Studio models into WhereScape? Okay.
Whether it's coming from Calibra or Ellie or ER Studio, you can import directly into 3D.
There you go. All
so
right.
If you've got a data catalog tool out there, you can jumpstart it and bring that conceptual model into 3D and start from there.
Yep. And somebody mentioned SQL DBM in the Q&A, looking at an integration of ER Studio and WhereScape as the new Oracle designer. Okay, Mark. Yeah. Yeah. And you can do that. You can actually do that. So that's good. That's good. Let's see. We got a couple other questions.
I'll just mention also that I was going to have a slide at the end. There's an organization called Data Vault North American User Group, DBNOG. They're having a presentation this afternoon. I think it's at 4 p.m. Central. I'll have a link at the end.
And 3 p.m.
3 p.m. Central?
Yeah.
Okay.
Yeah.
That's right.
Yeah, it's 2 hours, so it's 3 to 5 this afternoon through Central.
They have quarterly meetings that are all very, very good. So if you're into Data Vault, definitely check out the Data Vault North American User Group. Today's topic is integration of Ellie, doing a conceptual and logical model, and WhereScape's 3D. So they're going to build a Data Vault Business Vault model and implement it and get it up and running and working in about an hour and a half. Daniel Insted's going to be on there. He's going to have a section at the end called Words of Wisdom. And as I said before, it's definitely worth checking out as a user group. DVNOG, Data Vault North American User Group.
Yeah, and so there's a lot of options out there for data modeling. So yeah, there's one question here from Naresh. A few projects who ignore data modeling. What's your opinion? Well, I think you probably know my opinion at this point. If they ignore modeling principles and agile methodology, boy, that's, yeah, ignore modeling and agile. Long term, that project is going to cost you a lot more money. You may get things delivered sooner, but you're going to end up doing a lot of refactoring later. And that's where the cost is. It's in the agile world, we call it technical debt. It's like, you're creating technical debt by not taking a disciplined approach. Now, one of the challenges with data modeling is because of the history of data modeling, people have it in their head, well, it's like, oh, that's just going to take too long. But there are agile ways of approaching data modeling. Data Vault happens to be one of the modeling techniques that allows you to build the model incrementally based on your business priorities and based on the data you have access to. So you don't have to build like an entire 1,000 entity enterprise data model before you start your project. In fact, you shouldn't do that. You know, you may do a high level conceptual model, which just has the most important entities in it, and then go drilling down into that to your logical model for what you need to do now, what you need to do today. And then once you do that, you convert it, using tools like Ellie and WhereScape and other tools, you convert that into a physical model in the database. So, very, very important. Right along the lines, what's the purpose of data modeling in the context of database design in a banking sector? Well, it's just, again, it's applying standards, making sure the relationships, and in the banking world, of course, it's, you've got regulatory requirements. You need to be able to trace that data. You need to have an audit trail. You need to be able to document what are those relationships, how is the data related? If you've got regulatory reports coming out, you got to be able to back that up with facts. Why did we do it this way? Right. And a data model helps people understand that, helps people who are writing the reports to understand the relationships in the data. So they don't do something silly like what we used to call a Cartesian join, where they join two things together because they want those columns on the report. Not understanding the relationship between it is going to just cause the data to explode, because there's not a proper relationship between those two objects, that there's something in between that they need to have. So that's it's very important. Are there open source standards for interchanging data models? There's the ANSI standards, right? Of, what's a primary key, what's a foreign key, standard syntax for them in the SQL world. Several tools over the years, I know, like I said, WhereScape has the ability to import models from ER Studio and from Ellie. I know when I used Irwin years ago, it had the ability to import from a couple other tools. Oracle Designer had the ability to import from Irwin, but all of that was relatively proprietary at the time. Irwin did output to XML. And so it wasn't that there was an interchange standard, there was an agreed upon format. And it varied from tool to tool and what the tools could do as to whether or not you could really, transfer the models between tools. So, is there an open source standard? You stick with SQL, right? Basic SQL, ANSI SQL is a good place to start.
Kent, a question that came up that I was going to ask is, it disappeared. How can data modeling help in ensuring data integrity and accuracy during an audit? And I thought that would feed into the data warehouse automation and how that having full data lineage and documentation and standard development can really help during an audit. But does data modeling fit into that as well?
Yeah, I mean, data modeling fits in if you actually implement it, right? So building the data model in the sky and just making a pretty picture on the wall doesn't necessarily ensure data integrity. It has to be implemented at the database level, so that conceptual and logical models have to be turned into physical models and implemented in the database, right? Now, when it comes to lineage analysis, then having a tool like WhereScape that's doing the automation and building the code so that that the data went from table A to table B to table C, and in between B and C, we applied some math, right? So we generated annual total revenue by some calculations against the raw data, and that's all documented in a metadata repository. But that all starts with having a model and understanding those relationships. Again, the integrity of the data is based on how you implement it then in the database and in your data engineering pipeline. If you've got to make sure you've got the checks in there, automated regression testing, very, very important, ongoing monitoring. So if the data changes at the source and you get bad data come in, that your tests show that. If you're doing OLTP systems and you've got the referential integrity, foreign keys, primary keys enforced in the database, of course, that will show up. That'll cause an error in loading the data.
We've got a couple questions. We got maybe a few minutes left, coming up on the top of the hour. You see the questions as well as I do. I'm answering, is WhereScape, what is WhereScape for? Let me just answer that live then.
Okay.
So an extra little plug in here. So WhereScape, as I said, is involved in data warehouse automation. What does that mean? Everything from design to development to deployment to maintenance to operations. Anything that's pattern-based, anything that's repetitive, WhereScape can handle. It's got a lot of intelligence built into it, not just about the technical aspects. How do you write SnowSQL? How do you write Databricks SQL? How do you write Microsoft SQL code? What's the best way for optimizing strategies? But also in terms of Data Vault, what are hub satellites and links? How do I create a transform? How do I create a star schema with facts and dimensions? All that knowledge is built into WhereScape as well. So what is WhereScape an app for? It's for creating data warehouses, which now extends to data marts, data lakes, data lakehouses, data vaults, pretty much any large data structure. And through automation, it just rapidly increases the rate at which you can design and develop and deploy it.
Exactly. So I've got one here from Barry. This is a loaded question, man. What's your opinion of universal data models? And you said Silverstein. I assume you mean Silver Sun, and Marco. So I'm incredibly biased because the first volume of the universal data models I co-authored with Len Silverstein and Bill Inman. And, I think that they are great as templates and guides. Worked with a number of companies over the years implementing them. They're very, very detailed models. So they're really good, in my opinion, for getting you a jump start. They certainly aren't the end of the modeling for an organization, because every organization has its differences, right? And so you may use it as a guide, as a jump start. Or if you've already got a model in place, you can use universal data models as a QA to go look and say, hey, are there key concepts that we might have missed somewhere along the line? Marco had the universal metadata models. So yes, if you want to build your own metadata repository, great place to start. Of course, I'm a buy versus build guy generally. It's like there's so many tools out there like WhereScape and Calibra and the catalog companies. It's like, I don't know why anybody would build their own metadata repository these days. There are so many products out there. A lot of them are SaaS products. It's like, why would you build it? But it's certainly, they're definitely good guides. They're definitely good templates. They're definitely good learning tools for understanding these various concepts and how things relate, and looking at logical versus physical models. The Universal Data Models book, the Data Model Resource book, shows you how they relate to data warehouse design. So you have your enterprise type model, and how does that transform into, say, a star schema. So there's some good learnings in there as well.
I had a note passed to me behind the scenes saying that there is something called the Common Warehouse Meta Model XML standard.
Yes. I don't know how many people actually use it.
Okay.
Do you guys? Does WhereScape use it?
Yeah, that's how we get things. I'm assuming that's what we use to get things into 3D.
Okay, good. There you go. So that's I forgot about that one. The Common Warehouse
Meta Model XML standard.
Okay, there you go. So there's an XML standard.
Yeah. So on the screen, I've got one more plug for DDNOG. Like I said, that's this afternoon at 3:00 Central. A demonstration data vault modeling. Dan Linseth's going to be attending, giving his words of wisdom at the end. And if you want to take a screenshot or just write down this number 293-177017. Actually, I will put it in a chat for everybody as well. Can I grab that? I can't grab that.
Yeah. So you got one leading question here. What's the best data modeling according to you? If I want to build a data warehouse, hands down, Data Vault 2.0. If you're building warehouse, because it's the most flexible and agile approach. And there's tools like Data Vault Express here from WhereScape that help you generate those and generate the code. Anything you can do. And the reason I like the Data Vault is because it's standards based. It's a repeatable pattern. It's a repeatable process. And if you want to learn more about that, then attend that session this afternoon if you can, or at least sign up so you get the recording. And I think we got time for maybe one more. So John has in Agile, is a conceptual and logical model enough, leaving physical to the data engineer to split work between data modeler and engineer? My answer to that is yes and no. Can you split the work? Yes. But you need to have the physical model tied to the logical model. It doesn't do you, it makes it much harder to rapidly iterate if you divorce the two, right? If you're using, and I'm a huge fan of automation tools like WhereScape, is you can do the logical model, have it converted, migrated to a physical model, and then you hit a button, it generates the DDL, you go run it in the database. The data engineer doesn't need to be writing SQL. The more hand code we write, the more mistakes we make and the more technical debt we incur. And as soon as you do that divorce between the data modeler and the engineer and a logical model and physical DDL, you introduce risk, right? And a disconnect, because now the engineer goes, oh crap, it's missing this, and goes in and modifies it, but the logical model doesn't represent it. So now your documentation and your traceability and your auditability is basically shot. You show the logical model to the business, but what's in the database is actually something different. So I'm a huge proponent of keeping the two connected and doing what we call round trip engineering, making sure one way or the other that you keep them in sync. If you're allowing data engineers to modify the database design, there needs to be a review process so that it gets synced with the logical model. And don't say we don't have enough time to do it. It takes too much time, because if you do, it's going to cost you money in the end, because you're going to have this disconnect. And as soon as you got that disconnect, you've got a problem.
Yeah, that's, as I said with my example of programming, 75% of the time is spent in refactoring and fixing, and the more of that, that's where you get huge time savings. Kent, thank you very much. I appreciate it. Appreciate everyone joining us. I think that's all the time. We're past the top of the hour by a little bit. Right at the top of the hour. Hey, how about that? I did mention that in the chat, there is a link to the DDNOG North American user group. I pasted it in there without realizing Kent had already pasted it in there. There's a bunch of questions we didn't have time to get to. I'll follow up and make sure we get answers to everybody. If you do have questions, you can email us at moreinfo@wherescape.com. Be glad to respond to you. If you like the little teaser about WhereScape 3D, WhereScape Red, or design and implementation tools, you can email us at request. You can email us at moreinfo, or you can go to wherescape.com and request a demo there. We'll be glad to talk with you at whatever level you want. If you're just curious about what WhereScape can do, if you want to see a live demo, we'll be glad to talk with you, find out what your requirements are, and help you get some answers to whatever questions you may have. Hey, Kent, thanks very, very much. I appreciate it. I got a lot out of this, and hope everyone else did.
Yeah, thanks for having me, Patrick.
All right, so everyone else, thank you. Enjoy the rest of your day, and look forward to hearing from you soon. Bye-bye.